It
Thank
reminded
you so much.
me. It reminded me of a blog. There was a scientist who had written a similar blog, I think 3, 4 years ago. Um,
Okay.
and I like the quality, the way you described it. So it's very well written. I think I'm looking forward to your presentation. So wonderful work.
Thank you so much. Appreciate.
Okay. So we are here to listen to Monira's presentation. She worked with us for last 2, 3 months on wheat detections. So we and Monira used to have a lot of discussion, and I really enjoyed her innovativeness because she comes from
Hmm.
a finance background, and the way she catches things were really on top. She was always on top of it. So I
Yeah.
really appreciate the character, the way Monira you are progressing, and she has. By this time, you have also participated in a lot of data hackathons, right? So she is
Yes.
really, yeah. So I think Monira is really getting it there into the data science field very quickly, catching up with it. So yeah, and the blog that you wrote was really good. Well,
Thank you so much.
yeah.
It would have
So
been possible without your support.
no, it was all you, Monira. I just supported you. So let's if I know you wanted to describe the blog, so I think it's a good discussion we can have. So please go ahead, Monira, if you can share your screen.
Yeah, I'll do that. I think I don't know, my laptop is lagging. I'm not sure, so it might be a bit slow. Uh, you see,
I
the
think it's
screen I
still,
have shared.
yeah, it's loading. Let's give it some time. Yeah, we can see it now.
So basically, instead of just doing the PowerPoint presentation, I discussed with Mr. Nista that I can just have a walkthrough uh, to the blog which I have written, because it was more of a I have described mostly what I have done in the entire project. So basically, out of the many projects which was given as option in the Hive capstone projects, I have picked up the one which was involved agriculture domain. I have basically done a project on the multi-class with image classification using different CNN models. So basically, global emphasis on sustainable agriculture. Weed infestation is a critical challenge in sustainable agriculture at the moment, because it impacts the crop yields and also increases the reliance on herbicides by the farmers. So
Hmm.
the goal was basically to develop a model that can help the farmers to automate the identification of various weed species, reducing the manual effort and also improving the crop yield. So in this project, basically, I tried to address the need for precise weed identification by leveraging deep learning to classify 8 distinct weed categories over 17,000 images.
Mm-hmm.
Also, we have built user-friendly web application interface developed using Streamlit for real-time weed classification, which maybe on the later stage, if we can develop further, can be used by the farmers. So basically, the dataset which we have worked on was provided by DeepWeed, where we have used three CNN architectures, namely ResNet 34, ResNet 50, and Inception V3. And we try to compare the results to see which performs the best of them to detect the weeds, to classify the weeds basically. So we have tested on
Mm-hmm.
around 17,000 images. So at the beginning, we have done some exploratory data analysis. of the images which we had. So we could classify them which belongs to which class. Basically, this is uh, the visual interpretation of it. Some sample read images. And while visualizing the data, when we were moved on to the data and while visualizing the data set, we
Yeah.
have found that you can see in the chart that there is a big imbalance in between the different classes of uh, the, the weeds.
Mm-hmm.
So basically over here you can see there are this eight types of weeds, the Shinapel and the CM weeds and lantana and so on. But the negative one, which shows the maximum data are collected from that class, is basically the ones which did not could not be classified under any of those eight classes. So
Mm.
this kind of led to the imbalance of the data set.
Yeah, yeah.
So, and also moreover, when we did further analysis, we also saw that some of the classes were underrepresented, like class 0 and 3 were quite underrepresented compared to the other class 8. So that I have
Mm-hmm.
shown in details uh, in my Jupyter notebook. So I have a repo, I have prepared a repo in my GitHub account.
Mm.
So I have a whole repo under with all the collab notebooks of this, all in
Mm-hmm.
detail, the analysis and the graphical and the presentations. So basically, what we did is that uh, we first we took the three models as I have mentioned earlier, Resnet 50, Resnet 34, and Inception V3. But what we did is that we, instead of just using the pre-trained models, we also tried to build up a neural network from the scratch and see how that performs when it's been exposed to this data and how it can uh, find out I mean, how it can perform in detecting
Mm.
the right class of of the weeds. So over here you can see, I'll show you. So what we do is that we have used ResNet 50, ResNet 34 in Inception V3. But in case of ResNet 34 and Inception V3, we have used the pre-trained models just to see how both of these architectures perform. And then, in case of ResNet 50, we have implement three different type of variations. In
Mm.
case of ResNet 50, we have first approached by building up a neural network from scratch with very minimum hyperparameters. We just have used a batch size of 16 and dropout rate of zero point 0.5.
Mm-hmm.
And then we recorded the result, which was we could record the result which was performed given by the model by testing the data, by testing on the data set which we had. So I have summarized the performance of all these models in terms of graphs and also in terms of a table. So what we had seen that when we had tested our model, the plain one, well, we could see that the train accuracy was around 95%, but when it came to the validation accuracy, it was somewhere around 60%. So it kind of showed that there was some kind of overfitting going on there in terms of the data set which we had.
Mm-hmm.
And then when we had and also the loss also it seemed to be very high, started off very high. If you see the graph, it has it has started off very high, and then slowly it had converged down. But that was also around 30 epochs. So then we had tested all of them on over 100 epochs and using Atom Optimizer. And the validation loss also somewhere was very high. It was around zero point 0.5 to zero point 0.6, which was, I believe, was the highest among all of the models. So, but so we felt that this isn't enough. This is not what we wanted the result to be. So in that case,
Mm.
what we did, on the same model, we included two more variations. We included that augmentation, and also we have added the pre-trained weights for the resonance 50. So first we had experimented with the data augmentation, and in that case, we increased the batch size. We augmented the data, and also we increased the batch size to 32, and
Okay,
we
okay.
removed the dropout.
Monira, let me stop you
Yeah.
here. So, when you say data augmentation, can you tell me one or two different techniques you use to augment the data? What did you do?
Uh, we did some flipping and rotation and some
So basically, flip. What's that? Horizontal,
yes,
and then
and then
scaling.
we did
Did you do Z scaling kind of techniques, or
yes,
okay? So that way, at least you were able to double the size. You could also
yes,
quadruple
yeah,
the
also
size, or
increase,
maybe triple the size if you flip it vertically,
yes,
perhaps.
yes, yes, and
Okay.
also increase the number of images also. So there was a mm, like there was a imbalance in between the
Yeah,
images.
yeah, yeah. Yeah, but wouldn't that also increase the imbalance if were you able to decrease the imbalance and you kept the negative, let's say, sample untouched, right? Because you want to come towards a balanced data set. Only
Yeah,
then your generalizations will start making sense. So basically
yeah,
you ignored the negative samples, correct?
yes.
Okay. All right. Okay, go ahead.
So yeah, and that did improve. That did improve the
Yeah.
performance. So it seemed that the validation accuracy kind of improved to 85% compared
Wow.
to what it was at 60% earlier. So that kind of showed that it was helping with addressing the class imbalance.
I see.
And the
I
train
see.
accuracy remained somewhere around 97%. This was earlier also was 95%, so just stay around that area itself. And the loss also seemed to be decreasing for the train loss. That also seemed to have decreased, and also the validation loss
Yeah, yeah, yeah,
has.
yeah. That's a big jump between,
Yeah.
I would say vanilla ResNet 50
Yes.
versus say ResNet
Versus
34,
that
almost 30% increase. That's pretty good.
yeah. Yeah.
Uh,
So with that, and also we try to give it a we also try to experiment by seeing if we can just take the preterm weights of the resident 50 and see if
uh,
that will not bring any kind of difference in the result. So that also seemed to have did much better than the augmented one. That have seemed to improve and stabilize around 90%, showing more of generalization, better
yeah.
generalization. Though there was not much of difference in the losses, but the accuracies had improved.
Okay.
And then for both the pretend Vesna 34 and Inception V3, definitely they were pretend. So in their case, when we just trained the model and ran it, it showed better performance also. But though ResNet 34 did not perform as good as pre-10 ResNet 50, pre-10 weight ResNet 50. It must be because of the layers have been lesser than the newer network layers have been lesser than uh, the one at the ResNet 50. So
Mm-hmm.
in that case, it underperformed compared to ResNet 34 ResNet 50's pre-10 weights one, but not better than the vanilla one.
Yeah.
And in case of the Inception, that also we have experimented with the pre-10 one, and that seemed to be have outperformed all of them in terms of accuracy and also in terms of uh, yes, in terms of both the train and validation accuracy, and also the losses had been much lower. I believe it was the lowest of all because the train loss is around 0.15, while the validation loss was around zero point 0.3. So this has been the different experimentations which we had done with uh, the three different type of CNN architectures, and the result which we got was that the pre-trained ones seem to perform better than the vanilla ones, especially the compared to the ones which we had built from scratch. And Inception V3 had been the winner of all. And definitely the vanilla one had performed the worst among all of them. uh, because it had around only 60% dietitian accuracy. So this has been the result which we have got. So the overall observation which we had from this the whole project was that usually the preterm tends to perform better than the vanilla ones, and also when we as the depth increases, like for example the resonate 50 tend, tend to perform better than resonate 34. So as the depth increases, the performance also increases when it comes to
Yeah.
the classification. And
Yeah.
also we had seen that the data augmentation also did help while boosting the generalization. So
Yeah.
has been basically the overall observation from the whole project. Also, we have uh, yes, this has been the most of it, and I have also mentioned some of the future work which we can do if I want to further experiment with the models. Maybe I can try out with other architectures
Mm.
involving transformers or involving transformers like vision transformers.
Did you try the VIT?
I I haven't tried yet. No.
Yeah, it's good to try,
I
because yeah, in the end of the
yes.
day, yeah, it's basically. I mean, listen, there's no need to push and try to test 50 different models. There's no need.
No.
Sometimes,
No.
for a certain problem, if it is not too complex, you don't have segmentation, sort of complex segmentation tasks. You can still use a
Mhm.
model like, I would say, AlexNet, or perhaps, pre-trained is better because, the pre-trained models have been trained on
Yes.
uh,
Yes.
hundreds of thousands, if not millions of servers. So you'd rather rely on the wisdom of the weights that have been trained in those models than try to train it on your, two GPU cards or three GPU cards. So that's fine.
Mhm.
But at the same time, um, the only reason why would you try to train or try out the new models is from efficiency standpoints, because in the end of the day, when new chip architectures, whether local or in the cloud, are being deployed by vendors, then the
Mhm.
newer models are more compatible to solving that problem at a very energy efficient sort of,
Correct.
perspective, meaning they probably might go and use an iota of perhaps CO2
Yeah.
emission versus. But again, I mean, I'm not saying, it's not a fancy exercise. It's just something you need to explore. But so
Yeah.
that's why you need to try to train it and say, hey,
I will
yeah. The other
because I think
suggestion would be to. Sorry, go ahead. You wanted to say something.
uh, I was just saying I was just trying to explore transformers, so I still
Yeah.
haven't had a proper grasp on it. So that's the reason I didn't try it. But once
Yeah.
I
Yeah.
have a
Yeah.
proper grasp on the concept and everything, the methods and all, then definitely I will
Very good.
try
Very good.
on it, see how it turns out to be.
Yeah. Very good.
And yes, another suggestion. You're saying something, is that it?
Yeah. As is another suggestion is sometimes what people, back in the days, like 6, 7 years ago, what we used to also do is we used to add models to each other. For example, ResNet plus Inception version 3.
Yes.
There's So when you add models, you apply a stacking techniques. But
Yes.
again, I mean, maybe it's right now the data set is really small,
Yeah,
17,000.
it's 7,000 only.
So
Yeah.
there's no need to try the exotic techniques like adding models together because it's almost like I've seen sometimes memes online that a guy is sitting on a dining table and using a sword to cut a fish. So sometimes you don't need an exaggerated tool to solve a small problem. But I
Yes, yes, I
suggest
have
that
seen that too.
as yeah, so as the data set increases to, let's say, 1 million images or something, which
Mhm.
becomes a very interesting project, perhaps in the Middle East or in North Africa, there's a lot of need for such kind of problems that need solving, especially in agriculture. it
Yeah.
can become very, very interesting project. So, and then those complex techniques can be applied because you have a huge data. You
Yes.
probably
To
have
work on.
hundreds of classes, and then
Mm.
it starts making a lot of sense.
Yes. Yes. Because there's only 8 classes, so that's kind of very limited
Yeah, yeah.
area. And yeah, we also have had a demo on the uh, what could be the user interface of the if
Yeah.
we in future we can implement app, just the front end uh, user interface. We just made a demo video of it because I was Mr. Nista made it for me because I didn't have enough space in my laptop to download the PyTorch.
Wonderful.
I share with the
Is that a video you want to play? Yeah. Okay.
Yeah, as load.
yeah, it's not playing Monira.
Yeah, I think I don't know. This is the
Yeah, what
video
happened?
sharing
Mhm.
videos. Uh,
We can
Let
see
me
your
slide.
screen. We can see your desktop. Yeah. Now I believe you clicked on play. Yeah. So I think something is happening now.
So
Hmm.
It's there's a promise that something is going to happen.
but Miss Teresa, the other day when I was doing my hackathon and everything, when I was using the Google Meet, that was quite smooth compared to, I believe, Microsoft Teams.
Oh, totally. Yeah. Microsoft is a very special company.
Because during those days, it was like we had all the
Yeah,
meetings on Google Meet. It was very smooth.
it's just like AI. You know, you have to imagine that it's solving its problem. You don't need to see visually.
Uh,
It's like just trust me. It solved the problem. The video is not playing, so never
No,
mind.
it's
But I
not
think
playing. It's okay,
no,
Monira.
I think it's
You
yeah,
can.
okay,
it's not showing. I think there's something with the feed,
I
maybe
think
with the
this,
audio feed. Uh,
yeah,
no
something's
worries.
happening with the words also.
Maybe
Your words are all
shut it
breaking.
down, and try open it up
Yeah,
again.
yeah,
If you close it and open it again.
just stuck.
Oh yeah. Okay. No
Yeah, you
worries.
can give it to me, Monira. I already have it probably, but I
I,
Yeah.
reformatted
yeah,
it.
yeah.
So just give it. I
I,
can share on my YouTube channel, so we can have it there.
okay, okay.
Yeah,
I'll do that. I'll just
yeah,
share it on
sure.
Slack.
Yeah,
Yeah.
sure.
It is
Okay.
just stuck.
So yeah,
All right.
thank you, Monira. Then it was a nice presentation, really nice presentation. I mean, I liked your article all along. So
Thank you so much.
and I will send you your certificate, so I can actually show
Okay.
it over here. Take over this thing. And sorry, here. So I will. So it's 10th of January. I think the name is correct there, and I will share it with you. Okay, and you do have a certificate code, so anyone with that code can check your certificate on our system in right here.
Are you
Awesome.
sharing it, Mr. Mista? I can't seem
I
to
will share with
see
you.
it.
I will just send the PDF
Okay,
version to you on email, Monira.
okay.
Yeah.
Because my screen kind of froze, so I couldn't see if you were
Oh, you
sharing
couldn't
something.
see it. Okay, I'm going to send it over to you
Yeah.
on Slack and
Sure.
then
Yeah. Can you share again? But
Okay.
so I think the most important thing, Monira, is I found this very impressive. Obviously, you spend a few weeks time with us to not only gain experience but also gain exposure, because obviously you're trying
Yeah,
to
it was not few weeks. We did do for 2 months, I think. Yeah. So about 2 months we
Yes,
were.
yes.
yeah. I mean, I was kind of saying it like 8 weeks.
Yeah.
So so I mean, you spend good amount of time with us, so for that's very good. And what I think what I think I can offer is we can offer an interview with one of our colleagues, our partner company in Oman. I believe you have experience